Okay, so we're talking about the linear correlation coefficient. And one more time, real quick, let me remind you what the R stuff does. So I'll do a couple graphs here again real quick to remind you. And let's see. So if your dots go up in a perfect line, that's R is basically 1.0. It might be, 0.93, but it's close to $1. It's close to positive 1.0. And if the lines go down in a perfect line, that's going to be close to negative 1.0. Maybe it's negative 0.91 or something, close to $1, 0.91, same thing. Okay, now, whereas if the dots go up, but they do it a little more loosely, that might be like 0.82 or something, and if the dots go down, but they do it a little more loosely, that might be negative 0.88 or something. They're going down, they're mostly in line, but they're not perfect. If the dots are just like random everywhere, not forming any kind of line, then that's just R is basically 0. You might see a value like 0.12 or negative 0.08 or something like that. One of these values, basically 0. And also, last case is if the dots are in a pattern, like how about that pattern? But it's not a line pattern, right? That's still going to give you basically 0 because it's not a line. Remember, the R is a linear correlation coefficient, a measure of how much the dots line up, right? And R is always a scale from -1 to +1. R is. The closer you get to +1 or -1, the more it's a perfect line. This is a line going up to the right. This is a line going down to the right. And in the middle, it's just a random scale of dots. Okay, so here we go. Let's
Mr. Heron, I have a question.
Question?
So how can you determine if they're going to be like really close? Is there a way to determine like if they're going to be like really close together? The dots?
So the closer the dots are together,
mm-hmm.
the closer your R value is to 1 or -1.
The whole number 1, right? So like on your example, it's D would be 0.97. So those dots are going to be closer together, right?
Yeah, right. Because this is really close. Yeah, think about money. This is really close to $1. So that's close to a perfect line.
Okay, thank you. I just wanted to make sure because I was confused.
Yeah, so the closer R is, these are all R values here. R equals. Closer R is to +1 or -1, the closer, see my graph here? This is +1, they line up, and I said like 0.93 to give an example, right? They're basically lining up in a perfect line. This one, I gave examples like -1.0, -0.9. They're basically lining up in a perfect line. So the closer you are to 1 or -1, the more the dots fit a perfect line. Yeah. So which one of these, let's start there. Which one of these looks like a line going up, almost a perfect straight line? Well, in my example, it looks like this one, doesn't it? So that's going to be the one that's positive and up right there, positive 0.96. So that's going to be R is positive 0.96 because the line is going up to the right. Whereas this one here is going down to the right. And so that's going to be a negative close to 1. That's going to be the negative 0.91. And now the other two, so we got those two already. Now the other two are more of a random smattering, aren't they? This and this, they're not very linear at all. Now, which one tends to look like it's going up? Well, that one, a little bit. I mean, not very much, but a little bit up, and this one looks like a little bit down, doesn't it? So this little bit up one, this is going to be the R is positive 0.45, and this one will be the R is negative 0.35, because those are closer to 50 cents, 30 cents. They're less quality line. You're closer to $1, positive or negative. You're closer to a perfect line like these two. Negative is down, positive is up. These two are closer to 50 cents or even less than 50 cents. They're less than half good of a line. That one's up, positive, that one's down, negative. I mean, through the middle, basically. And yeah, that's all the parts on that one. So there we go.